Hey there, welcome back to Farmcraft. There's a constant supply of things that need fixing on a farm, and I've put several together in this video. Some require some creative solutions and some interesting techniques. So let's get into it. So this is an air-powered grease pump, and I really like this thing because I can pump large volumes of grease. I don't have to deal with the little tubes. There's a 5-gallon bucket of grease in there. I cover that to keep the mud daubers out, but I just hook that to my air compressor. And that powers the pump, which then draws grease out of the bucket and into this hose. Pretty simple. When it's hooked up, you pull this trigger, grease comes out. The problem is, this is a cheap one. I didn't pay a whole lot for it. And this hose, which it's not very old, but I guess it's a defective hose because grease squeezes out of the hose in multiple places. So I've already had this off. But I thought, well, I'm just going to go get a new hose. Well, it turns out that fitting is unobtainium. Yeah, this fitting is a strange fitting. You can see it's a flare. I measured the angle on it. It's 45 degrees. Well, SAE is 45 degrees, but it's a metric thread. It's not SAE. This does not unscrew further. There's no port there for me to try to work off of. And going into the gun, I've got the exact same fitting. It's like a metric version of SAE. And I don't know, I looked on Google. That's the other thing is, like, if you measure these threads, it's like 13.7 millimeters. It's not even an even metric, but it is a metric pitch. I believe it's 0.5. And the other thing, you know, grease is very high pressure. This hose is 60 MPa. I think that's like almost 7,000 PSI. You need more than just a regular hydraulic hose to handle the pressure of grease. So yeah, I thought, you know, this isn't worth filming. I'm just going to go get a new hose and put it on there and roll on. But since I can't get these fittings, I've already been to the hydraulic shop about this, and they don't know what those fittings are either. I really have no way of making a new hose that goes onto here without some creative work. I guess I could machine a brand new fitting to go onto that, but that would actually be pretty tough to do. I think I have a solution here. Let me show you what I'm going to do. So what you have on these fittings, pretty much all hydraulic fittings, is a crimp ring. This got bent, deformed into position with the hose behind it over a hose barb. So this piece here is a hose barb going down into the hose, and then this crimp ring is around it, holding it. What I wanted to do was just cut the crimp ring off and bring it to a hydraulic shop and have them put a new crimp ring on and just re-crimp it with the same hose barb. But they said they don't have crimp rings for that. I know that's possible to do, but what they suggested I do is basically braze this hose barb onto a JIC fitting, and then I can just use a JIC hose. So that's what I'm going to do, but I'm going to take my time cutting this apart. I want to make sure I don't damage any more of the hose barb than I have to, and see if I can get it apart. Kind of for future reference. I've never done this before. Alright, well, there's your hose barb. So I think for what I'm going to do here, I could get away with just cutting that off. But I want to see if I can get the crimp ring off, because in the future I may be trying to actually do this and use the hose barb again as a hose barb. Almost got it. Still won't come off. Alright, so there's our hose barb. And in that little groove right there, that's where this crimp ring was crimped on and then crimped further around the hose. So pretty simple the way these things work. You just need the right tools to be able to do it. One day it'd be nice to have a hose crimper. You can see that's a really heavy crimp ring, or what do you call it? Crimp sleeve, I think they call that. That's thicker than your typical crimp ring. I think I'm going to grind this little ring here off. Alright, so now I need a hole that is the appropriate size to braze to. In this is a JIC plug. So the first thing I want to do is drill this out so that it's just a touch bigger than that. You don't want it, you want room for the brazing to get in there, but you don't want much. So that turns out to measure just over 1/4 inch, so I am 1 bit up from 1/4 inch is what I'm going to drill it. I found this piece of rod that fits in the fitting very well. I put that in the tailstock, so that's going to help me center it in the chuck and get it running true. That's pretty tough steel, and this bit is struggling, so I'm going to get a higher quality bit. There we go. So that fits in there. Just a little bit of room for the brazing around it. Just going to have to figure out how to hold it, because this thing flopping around is just going to make it a little bit challenging. Now what I want to do is take a nice clean file and scuff up where I'm going to be actually expecting the braze to stick. A good clean rough metal there. And another thing I really need to do is learn TIG welding, and that's actually on the list in the near future. I think TIG welding this would probably be maybe even a better option. But I need to get good at it before I'm doing something like this. Turns out a battery post puller actually holds that just like I want, so that I can put it down in there. I'm holding it very lightly in the vise so that I don't deform it, but this turns out to not be the best idea. I've got my fitting there ready to go. I've got my brazing rod, brazing flux, and oxyacetylene. And basically you heat it up until it's cherry red, and then you apply the brazing and it should flow into the joint. Now, to increase my chances of success and reduce the chance of a leak, I am going to try to get some flux down in the joint. Generally you just do flux on the rod, and maybe what I'm doing isn't necessary, but I don't think it's going to hurt anything. So I'm preheating the fitting a little bit so that the flux will stick. And now I'm preheating the brazing rod and dipping it in the flux. The flux is a powder, but it kind of melts and sticks to it. So now I'm spreading flux on the fitting, making sure I get plenty down in there. And as you heat it up, it kind of melts and spreads out. So now you want to heat the metal until it will melt the brazing rod, and it takes a while, and I keep trying, and then I'm melting the flux off of the rod, but the rod is not melting yet, which you can see here in just a second. No brazing has gotten on that yet. So I'm using the end without flux now because there's plenty of flux on it already. And there you can see that brazing has started to melt and flow around the joint. You see kind of a fillet there, right around that joint. So I work my way all the way around, making sure that the brazing is very liquid and flowing easily from all sides. I get some better footage on the second adapter that I do later in the video. Why does it always feel like I'm doing stuff where I don't know what I'm doing? I didn't braze that to it, that's good. Clean that up on the wire wheel. So now the question, does it still screw on or did I warp it too much? Oh, that feels good. And I realized holding it in the vise like that was probably not the best idea. Yeah. Looks like about 8 or 9 thou that it's now egg-shaped. But, you know, this just being for a grease hose, I bet you that'll be fine. If it's not, I can take this apart and do it again. What I'm going to do on the next one, rather than holding it in the vise, I'm going to hold the rod and just put the fitting over the rod and hold it like that. That's what I should have done. So I'm pretty happy with that. I think that's going to work. And you know, the nice thing about brazing is if I mess that up, I can heat it up and take this back apart. If I weld it, you're kind of in a different ball game. You could potentially ruin this. So I can see the advantages of brazing, although I do want to be able to TIG weld these in the future. And yes, I could have machined this. I would have had to single point thread it because I don't know what thread that is. It's 13.7 millimeters, a 0.5 pitch. You get the point. Machining this would have been harder, would have taken me longer. This is a pretty cool way to make an adapter real quick. So now I have an adapter to go from this mystery thread to good old JIC. For the record, if this was going into an actual hydraulic system, I wouldn't be happy because I did warp this thing a little bit. Because this is just a grease hose, I don't think it's going to be a problem, but that's the beauty of these flare type fittings. There's another flare inside that matches with it, and when you screw them together, you're generating enough force to actually deform the metal at the flare and force those two faces against each other tight enough to seal. So I think the few thousandths that I'm out of round would probably be overcome by just tightening it down. I guess we're going to find out. I'm obviously not going to worry about that until it's a problem. Now the other end of this hose, I don't need to be as careful because I kind of know what I'm doing now. I'm just going to cut it off and leave myself enough room. Well, that went a lot faster. And I need to point out, several people mentioned that I should use 2 cut-off wheels side by side to keep from having them explode when you're using them, as they often do. And I have to say, that seems to be working. So yeah, thanks for the tip. All right, that's acetone. I actually cleaned the first one I did like this too. I just didn't put it on camera, so want to get all that grease off of there so that the brazing can stick. And I'm leaving this one a little bit longer. Previously I ground that ring off so that it would come all the way to there, but there's just no need to do that. I'm just going to leave that ring there and have this thing sit down in there like that. Alright, well that rod is coming all the way through the fitting there, so I need to lift it up a little bit so that my braze section goes together where I want it, and I'm just going to hold it in place with a pair of vice grips. Nice. And don't forget to put this on before you braze it. So like I did before, I'm going to get some flux down in there. So ideally I like to get the metal hot enough that it will melt the brazing, but it's kind of hard in this small area. You got to keep the torch on it and you end up melting the rod with the torch itself. Like I just did there, but it's not really a problem. It leaves kind of globs of the metal and you have to keep heating it until it flows. So that didn't flow great, and then right here I definitely see I'm just melting the rod with the torch and it's leaving those clumps. That's definitely not doing anything yet, but if you continue to heat it, it will liquefy and really flow and fill that joint. Brazing is actually pretty forgiving. You're not in a big hurry, you've got plenty of time, and you can always redo it if it doesn't go well. And right here I think is when it really starts to flow. And I'm probably putting more on than I need, but that's okay. You know what they say, the bigger the gob, the better the job. Yeah, see those globs are gone. And I do a little more heating on the far side. You can see it's really liquid there. And I think we're good. Alright, if you look around it, there's one part. It was leaning a little bit. It's actually not straight. And yeah, right here, there's, you know, it looks like a void. And that concerned me when I first saw it. But when you look inside, you can actually see that the brazing flowed all through the joint. So I think that is going to seal just fine. And if this does end up leaking, I'll just heat it back up and get that brazing to flow a little better. And that'll probably fix it. We now have our adapters. This is the JIC hose I had made up. .690 bar, 10,000 PSI. That's quite a hose. So we can go install that on the grease pump, and this thing should be fixed. Hopefully we won't see any grease come shooting out of here. Alright, we are about to find out if this thing's going to work. Because when you plug this thing in with air, it pressurizes this whole line. The only thing stopping the grease coming out is the trigger on the gun. So we are going to have grease in that line in just a second here. So it's 80 to 1 and it's 90 PSI in there right now. So it's 7,200 PSI in this line. And I don't see any leakage. So that's cool. And being able to braze a fitting like that is a nice addition to the skill set. That's pretty handy. Because you come across a fitting like this that you can't get, well, just get one that you can and braze the two together and you're good to go. And brazing is amazingly strong. I talked to the guys, this was at Tipco, the hydraulic shop that I was working with, and asked them about the strength of the brazing, and they said it's bomb-proof as long as you do it right. The brazing can easily hold the 10,000 PSI, no issues there. Alright, so let me show you something else that I do with these with this grease gun. Tubes like this are expensive and I find them very annoying. If I have an option, I will grease with this, but sometimes you need to be portable. In those cases I opt to use, you know, these tubes. But I run out of them and I have to go buy more, and they're like $8, $9 a piece now. Whereas this bucket of grease is really cheap as far as per unit of grease. So I just refill them, and it's really easy to do with this. So the grease pump has been sitting outside, and it's really cold out there, so the grease is really cold right now, so it's flowing slow. It might have taken me, I don't know, maybe a minute to fill that up, but usually it's just a few seconds. It's more than twice as fast as that. But either way, it's a lot faster than running to the store and buying another tube of grease for $9. Okay, we are at about 115 PSI times 80 comes out to just over 9,000 PSI in that hose right now. And fittings look great. No leaky leaky. So I just unplugged the air hose and then squirted the last bit of grease through so that there's no pressure sitting there in the pump while I'm not using it, because I'm not going to use it for a while, I don't think. Now they do make grease guns that you can unscrew this and just draw it up out of a 5-gallon bucket. At least all the ones that I've seen, you do that or you do this. You can't do both because the size seal and the size of the cylinder here is different. Or maybe you have to flip something around for it to do it. And I just never wanted that much trouble. When I go out in the field to grease a machine and I'm not near the shop where I have this pump, I want to be able to just use tubes. Because if I'm out there and I run out of grease while I'm in the middle of doing the job, I can just grab another tube, throw it in, and roll on. I don't have to come back and pull it out of a bucket. So I wanted to keep my grease guns in the standard configuration, but being able to refill these doesn't seem like much, but it is a big convenience when you're dealing with this kind of stuff a lot. So pretty much the only time I feed hay is when it snows. The cattle, they can kind of learn to eat through it, but we like to push them and make them eat all of the grass. So unless there's like a really abundant field with tall grass, they tend to just not eat if there's snow on the ground. So we give them hay to get through, and they appreciate it. Other than that, it's all rotational grazing. This next repair is going to make you want to buy a lathe. Being able to fix things like this without any trouble is just so rewarding. So I got a little problem with my forks. I want to fix this right this time. This handle right here I made years ago out of a piece of mild steel, and I wish it was bigger and easier to grab. So what these do is you pick them up and rotate it around. There's a little spring-loaded pin. It holds it from going down into this detent. So in that position, you can move this where you want. But then when you rotate it, yeah, there now the pin is free to fall down in. So I don't know if you can see there. That pin just spring loads down against that. So obviously when you want to move these a large amount, you bring it over this way so that the back of that holds it up off of this. And I didn't make mine long enough, so that's one problem. The reason I made this one is because the original one fell off, and well, now the other one's fallen off too. They were originally held on with a roll pin. It's just a bad design. I have mine on with a cotter pin, which has worked just fine, but I want to make two of them that are correct and work right. So I'm adding a 1/4 inch to the height, and then it's going to be another 1/2 inch on this diameter up here. So that comes to 1.5 inch stock that I need, and the total length of the piece will be 1.2 when I'm finished. Then I'll have to drill a hole down through it. Should be pretty simple. And I've got this 1.5 inch aluminum bar that I'm going to make it out of. It's a nice grippy knurl. There. So now that's down in a detent, and if I take this and spin it around, no, it's not. Yeah, that's perfect. That's what I'm looking for. So now I need another one. That's why I made that knurl so wide. So after I cut this one off, I still have enough to make another one. There you go. That is so much nicer. Easy to grab. It's working properly. It's not going to rust. And yeah, with those cutter pins in there, that's not going anywhere. At least not for a while. So here you can see right now this fork is locked, but if I pick it up and rotate it, I can push it over and then lock it back in. And that keeps it in position while you're working. So this one's locked right now, and I use the handle. I can move it over and lock it back in. When you're out in the field picking up logs and things, those forks tend to move around, so the locks are very important. Hey guys, got a little bit of news here. We have revamped our merch store, and we finally have international shipping. So if you've been waiting for that, we've finally got it. We've added some new merch over there. We've got beer koozies, a new t-shirt, and we're going to have other shirts and stuff coming in the near future. Right now we have a bundle on the Keep 'em Running t-shirts, so check that out, and we'll let you know as more stuff comes in the future. And now for something a little different. We're going to go see the biggest wood chipper I've ever seen in action. Gonna go get some wood chips. This thing always starts right up. Here's a good logger that I've worked with in the past, and he's got a job pretty close to me where I can go pick up some chips. The log loader here is kind of the central hub of the operation. It sorts all the different material based on size, species, into the various uses that it'll be used for. Much of it is going to go to the sawmill and be turned into lumber. You can see he's got some big logs here and loaded on the trailer here. A lot of it will go to the paper mills and be used for pulpwood for making paper. And I think that's what this trailer is loaded up for here. And the rest of the trees that doesn't really have any other good use tends to get chipped. And it can be used for various things like mulch. A lot of it gets sent to power plants and it's burned to make electricity. So the first time I came to pick up chips, I expected to see a giant pile of chips in a loader and just have them load my truck, much like when you go to the stone quarry. And I showed up and there was no pile of chips, there was just a chipper sitting there. I was a bit disappointed. I thought, man, I'm going to be sitting here for a while they fill up my truck. So let's see how long this takes. I tipped the bed up so that the chipper can fill the bed more efficiently. Logging is one of the biggest industries in the rural area where I live, and I think it's poorly understood. People see the trees being cut down and they think environmental destruction, they just think negative things about it. But these are just a crop. The trees get replanted, they grow back, and they end up getting cut again. And all the wood that gets turned into lumber then gets used in structures, well, that's tied up a bunch of carbon. And then when the forest is growing back, it's again taking a bunch of carbon from the atmosphere and tying it up in the form of wood. All the chips that are made here and then burned in a power plant, that's offsetting coal and fossil fuels that would be burned instead. And the carbon that came from those chips was taken from the atmosphere and returned to the atmosphere. So it's just a cycle. I don't see the timber harvesting as a bad thing. It's just like cutting a field of corn or soybeans. It just took longer to grow. Now let's check out this chipper. It has a 420 horsepower Cummins engine running it, and it has a 20-inch capacity. The guy that's running the log loader also is running the chipper remotely, and he can control how fast it's feeding, the size of the chips, things like that. He can pause it if it's starting to bog down a little bit. And you can see that the trees he's putting in are big, but they're just too small to make lumber out of. This is a semi-trailer for hauling chips. This will be loaded full and then brought to a power plant for burning. I really need to add a cover for the bed of this truck, but I don't have one right now. It's on the list. But surprisingly, you don't lose that much driving. In fact, even after driving all the way home, I still had quite a few chips laying on the hood. So this is all hardwood. We tell them no sycamore and no walnut because we use a lot of it in the garden, but we also just use it as a general mulch, and does a really good job, lasts a long time. That whole truckload is 125 bucks. Like, how many bags of mulch is that? This thing's up to my chest. Here's our next repair. This is a cast iron stovetop. So here's a repair I'm going to attempt that might end up being a total fail. So this belongs to a friend of mine, and I've told him that the repair may not work, but he wants me to give it a go. He has several of these stoves, and here's another one of his that I'm showing. This is made by a French stove company, and I'm going to butcher the pronunciation, but Godin, I think. It has developed a crack. Now, this is enameled cast iron, and you can see the crack here. It comes through there, and it looks like it goes through that one too and stops there. Could possibly be a little bit there, but the rest of the ring is intact, this main outer ring. Now, cast iron is brittle, and the concern is one more wrap or drop or something, when this is free to move, it's going to crack the rest of the way through, and this thing's going to be in two pieces. So he wants me to try to fix it, and the best way I know to fix cast iron is by brazing. It is possible to weld it. It's very difficult. It's easier to braze, and that can be difficult too. This enamel on it, I'm just not sure how that's going to react. I don't think it'll be a problem. It may make it look bad, and I warned him of that. He's fine with that. You know, we could touch it up with some high temperature paint or something if need be. So my goal with this really is to get this outer ring intact again. So that's what I'm going to start with. I may, just because this one's a pretty decent size crack there, if this goes well over here, I may do that too. And those two together will lock it in so that if it were to drop, it wouldn't excessively do anything to this. In other words, it would make the ring intact again and a lot stronger. The big question I have is, am I going to cause more cracks with how hot I need to get this? Because you got to get quite hot for brazing. And then how is the enamel going to react? Is it really going to mess it up? I imagine there's somebody out there watching who knows the answer to these questions, but I don't, and we're going to find out. The first thing I need to do is grind out some area for the braze to live. We're not worried about what it looks like on this side. This is going to look ugly when I'm done, but that's fine as long as it's stuck and it's strong. So it doesn't look like it on camera, but I've adjusted that to a neutral flame, and I'm going to start out just heating the whole area. I don't want to really get hot in one spot and cause other cracks in the cast iron. So I'm just sort of giving it an overall heating first before I focus on the crack. And here I'm preheating the bronze brazing rod and then dipping it in the flux And I like to get some flux on the crack before I get too hot, just trying to prevent any oxidation. And now that everything's getting hotter, I start to focus more on the crack so that we can start to melt some brazing. Looks like the enamel is melting. The braze is not yet. My camera didn't do great at filming this, unfortunately. Sometimes it handles the light really well, even when I'm welding. But here, it just wasn't adjusting the exposure to be able to see the braze under the flame. You can't see it with your naked eye either. You have to wear tinted glasses. But basically, you're looking for almost like a weld puddle. You can see the molten metal, and you're adding it as needed, and just trying to fill the gap. And it actually looks pretty good here, but the braze was kind of humped up, and I was worried that it hadn't really flowed and bonded to the base metal as well as I would like. So I decided to keep heating it and add a little more to make sure I had a good bond. The end result is a little uglier, but I do think it's a stronger, better repair. I cover it with some ceramic insulation to let it cool slowly. If I let it cool too quickly, there's a chance that I would cause a crack somewhere else in it. Well, there's way more brazing on there than there needed to be. That is definitely bonded. And brazing is very strong. I think that will protect this from an easy crack in the future. Obviously, you want to avoid dropping it. Now this side, that's going to be up to him what he wants to do. I wonder if you could just get some high temperature paint, sand that down, and then just paint the whole thing. I don't think going in on any of these little cracks is going to make sense because I'm going to mess more of the glazing up, and that would be even more difficult to get it to look right in the future if it's all bubbly like this. Yeah, I think that's going to do it. You can get a close-up of what that looks like. Not the prettiest thing in the world, but should be strong. And the enamel I messed up. You know, I suppose he could look at getting this thing re-enameled. I'm sure there's companies that do that. Kind of ugly, definitely strong. I'm calling it a win. So there you go, guys. There's a random compilation of farm fixes and farm chores, none of which I thought were worthy of their own video, but put together, I think, made a pretty decent video. What do you think? Did you like it? Should I do more like this in the future? Either way, thanks for watching, and we'll see you on the next one.